Welcome back. We're going to do conceptual review of kinematics for the kinematics units. This is actually the graphic representation of all the stuff that we talked about, the motion. So here it is. We're going to start with the graph of d versus t in the uniform velocity for the uniform velocity. And then we're going to talk about the non-uniform velocity and then what will that be. That's just a review. So if you have a dt graph, if you see a uniform velocity, that means you're going to see a straight line of some kind. There's not going to be a curve, okay? So the simplest form will be a straight line, just like what you see here. Okay, this is a uniform velocity. That means that it's not changing, it stays the same. And the slope of this line, so that's the important piece right here. The slope of this line is the velocity because slope is rise over run. So you can go up. So you go up for rise, then you go across for run. So basically you have d on top of delta d and then delta t and the horizontal. And that's what the velocity is, rise over run. Okay, so rise over run, and that's the slope of a dt graph is the velocity. All right, simple as that. Now, what happens if this graph is not uniform velocity? Well, the graph is going to change. It's going to look like a curve. Well, here is the example of that. So here is an example. If a non-uniform velocity d versus t graph you see, you're going to see a curve like that. Okay, and this curvature of dt, well, to get the information out of this graph, we can actually find what is called as instantaneous velocity. And how you do that is, as a reminder again, first for a specific time interval, let's say point, this is the at time t. Once you have that point selected, then you have to draw a tangent line to that point and then take the slope of that tangent line. So here it is. I drew a tangent line at that point T, and the point, that's the only point that this line touches the curve. And at that point, if you calculate the slope of this line, so again, you can do the rise over run, and you can use that point as well, by the way, that's no problem. And then you go across again, so rise, either you can come down or go up, it doesn't matter, but as long as you're consistent. So this is the run value, this is the rise value, okay, and it is positive, okay, and then you just find the slope of this tangent line, and that becomes the instantaneous velocity. So here it is, the slope of a tangent line at t is instantaneous velocity at t for a graph, for a motion that is not uniform. Okay, it's a non-uniform motion, that means non-uniform velocity. All right, and that's the another example of the distance versus time graph, which is very important to remember. Okay, let's look at another topic in terms of the graph, and that is the graph of velocity time graph. And what that means? Well, that means if it's a straight line, so I have this graph again, velocity in vertical, time on the horizontal. If you have a straight line on the VT graph, let's call that a VT, that's VT graph. This straight line represents uniform acceleration. The slope of this graph, okay, again, the slope of this graph is equal to the acceleration. So the slope of a VT graph is the acceleration. And again, you can go ahead and do the rise over run. That's what you're doing, right? Rise is the delta V, and then that is delta V, and that's delta T. And when you do this, you'll get the acceleration, which is the slope. Okay. Now, there are two different kinds. One is the uniform acceleration that you see the straight line that doesn't change, right? And then you got a non-uniform acceleration, and that is basically you get a curve. Okay. And when you do a curve, the same as the non-uniform velocity, where you got a curvature motion, it looks like a curve, and it is. Then with the non-uniform acceleration, you'll get the pretty much the same idea. So in this case, you do the exact same thing, but the only information that you can get out of a non-uniform acceleration is the instantaneous acceleration at even that at given t. And again, what is it? Well, the slope of a tangent line to the curve of the VT graph at the point t, at the given interval t time, that will give you instantaneous acceleration. All right, so make sure you remember this because it's very important. And that's the only information that you can get for the purpose of this unit. Whenever you have a non-uniform acceleration, you can also get the instantaneous acceleration out of that. One last thing, and I need to talk about, and that is the acceleration time graph. Now, this is the graph that is very interesting. When you have acceleration time graph, this is a special case, all right? So for the most part, if you have a setup like this, like a straight line, that tells you that acceleration, for whatever the acceleration is a constant acceleration. It's not changing. Whatever it is. Let's say this one is at 10 meters per second. Let's say this is 10, and the unit is meters per second squared, and it's going to go on in the whatever time interval that we set it up to be. And this straight line tells you that the acceleration is not changing, and the slope of that is 0. That means that there's no change in acceleration, it's constant. Okay, so that's the only thing. And then the one thing that you may want to remember is that the area under the line within the time interval, whatever time interval you choose, let's suppose we choose it to be to this area right there. Well, the area under this line is the a times t. So this is t, whatever the time interval is, and this is your a, which is acceleration. And remember, acceleration wasn't that delta v divided by delta t. And if you rewrite this, delta v is equal to acceleration times delta t. Well, here it is. This area right there is your delta v, but it shows up depending on the question or depending on the context. It could be a final velocity or it could be the actual delta v. You have to pay attention to that. Okay, simple as that. Not complicated. Just stick with the main idea of the and very simple, basic parent equation for acceleration to analyze the acceleration time graph. All right, this is it. Make sure you check out the quiz in the description below or in the pinned comment. And until next time, keep at it.